Hi everyone, welcome to the Kotlin London Meetup. So we're now at our fourth line event, and this month we have some changes, technical changes. When we started, we had no experience in streaming live events and no budget, so we went for a solution like a homemade solution based on the OBS and Google Meet calls. It worked well. We had a lot of positive feedbacks from you and from the speakers, but it was technically complicated and very CPU demanding. Uh, uh, we have to say big thanks to Guillermo, our co-organizer, managed to make it work very well. But we needed an alternative. So we found an alternative in StreamYard, which is software that let us to manage all the streaming in a much easier way. Unfortunately, to keep the streaming as professional as we would like, the free plan was enough for us. But luckily, we have found a sponsor that pays our basic plan. So thanks to 47 Degrees, it will be our sponsor for this meetup and for the next meetups. We now have a free plan. We can deal with everything. So I would suggest you to check out the academy with there are a lot of courses on Kotlin and on functional programming. The link is in the description below, so absolutely check it out. If you want to try StreamYard for do your own streaming, or if you know someone who wants to try it, please use the link below. You will get a discount. We will get a discount, and you help us to get a bit more money in terms of referral to run the meetup. We hope that everything will run smoothly, and forgive us if there will be a small hiccups, but I'm sure that everything will be fine. So if you haven't done it yet, please join our meetup page. Subscribe to our YouTube channel and follow us on Twitter. But also speak to friends and colleagues who might be interested in watching the video. We share the link on the usual channels afterwards, or if they are interested in giving a talk. Well, I think that's it for the intro. As usual, we have two talks. Our first speaker is Mohit Sarveiya. He's from New York, and will give us talk about gRPC with Kotlin Coroutines. Our second speaker is Uberto Barbini, who already had a talk a couple of years ago at Kotlin Meetup. And it's based in London, and he will talk about validity requirements and domain with his library he created. It's called Pesticide. Thank to our speaker to accepting to speak at the meetup. The Q&A will be done after the second talk, and the question for asking a question is in the link is in the description below. During the talk, as usual, I say, please add a small feedback in the comment section, thumbs up, a clap, just a small feedback to our speakers, because speaking an online event can be very lonely. Sometimes it's difficult to have a feedback. So anything in the comments will be great. So I think that's it. We can easily switch to our first speaker of tonight, Mohit, talking about gRPC with Kotlin Coroutines.
Hi, my name is Mohit, and I'm going to talk to you about gRPC with Kotlin Coroutines. So my presentation is about, I'll share with you how to use gRPC, how to build a server and a client. So I'll show you a simple use case for using gRPC on the server side and how you could utilize channels and flows with it, and also look at how to consume it in an Android app. So how does gRPC work? So RPC stands for Remote Procedure Call, and Google has a framework that you could for it. So the way it works is that the way you would set it up is that you have a server in which you define a service in which you define all the RPC calls that you could make, that the client could make, and the service is defined using something called protocol buffers. which is like a formatting language in which you could define all the different types of requests that could be made and the different types that the client could get and send. So, you usually have clients in different languages like JavaScript, Python, or Java, or like a Kotlin, and your server is also like usually in a different language. So, gRPC and Protobus, they provide a way for you to generate a stub on the client side that you could use to utilize to make RPC calls to the server. And there are different types of RPC calls that you could make that I'll show you what they are. And these RPC calls are made using HTTP2. So that's the general setup of like of a RPC setup. So for this example, I'm going to show you how to build a client and server using two different libraries. So on the server side, we're going to utilize Croto+. On the client side, we're going to utilize a library called gRPC-Kotlin. So I'm using two different libraries to show you like two different technologies, but you may also have a server that was written many couple of years ago is using a different technology. So suppose you had a sample use case where you're trying to build an app that tracks your route as you go from point A to point B, and through your route you could check into different places. So you could, as you go and in your journey, you could click on a location on your map and get information about what's there. And you could also specify an area in your app and get all the locations in a particular area and around the location. You could also, chat with others and, at a particular location, you could send messages to them. So how do we build such an app and implement such a use case on the server and client side? So the reason why I chose this use case is demonstrates all the different types of RPC calls that you could make. So let's look at how to build an RPC server. So we're going to do four things in order to do this. We're going to first see how we could configure our server using this library called Croto+, and how do we define all those different types of RPC calls on the server side using protocol buffers. And we'll look at how to implement logic using channels and flows. So Croto+ is a library used a lot, and it provides you with Kotlin-friendly ways to deal with protocol buffers, and it provides you with coroutine bindings. So the way, if I was building this on the server side, I would create like a microservice, and I would break apart my code in different modules, where I have a server module that has code to read from the client, and I also have code I'll probably query a database when an RPC call is made. So I'll have a module for all my database logic, but also I'll have a module for my API where I define using Protobus all the RPC calls that could be made. And the common pattern is that this is defined in a folder called Proto, and then in the Proto folder you have a file. In this case, my example, I have a file called places.proto that I'll define all the RPC calls in. So what goes into that file? So let's look at the format and what you would put in there. So to define all the RPC calls that could be made. So first, I'm defining a syntax. So I'm defining what version of protocol buffers that I'm going to use. So there's version 2 and 3. There are things in 3 which are not backwards compatible with 2. So I'm going to use version 3, and then I'm going to define my service like this. So service is a keyword, and then I have my name of my service, and what goes inside that block is all the RPC calls I can make. So the first type of call we'll look at is called a unary call. So the way a unary call works is that you have a client which is making a request to the server, and you're sending a location to the server. So in my example, I'm going to send a location to the server, and it's going to give me back what's at that location, a particular place. So this is the simplest RPC call. How do we define this? Here's an example of how to define it. So let's look at each part of this definition. First, you have your keyword RPC. So every RPC call begins with this keyword. and then you have your name of your RPC call that you're going to make get place. And then I'm specifying that the client is going to send a message, which is a location. And I'm going to return. So returns is a keyword. I'm going to return a place. So how do I so this is the simplest RPC call, but how do I define these two requests and responses? So the way they're defined using protocol buffers is like this. I have a keyword called message. So every message is defined with this keyword. I have my name of my message, and I have the fields that are part of that message. And this location will have a latitude and a longitude. So each field that you declare has a particular type, and this type maps to a particular type in a language. So a double maps to, like in Java and double, you have int32 maps to an int64 will map to long in Java. So the protocol buffer compiler, when it generates your code, will map it to one of these language types. So each field that you declare in your protocol buffer file has a unique number. And this number is, you could choose from 1 through 15. It's used to encode the information in binary encoding. So the other thing is that so we have defined our location. How do we define our place type message? Well, similarly, the same thing. I have my message keyword. I have a string, but I'm also referencing an existing message called location in there in the second field. And then a place could be anything, a restaurant, a golf course, etc. So I could define an enum using protocol buffers where I have an enum here called place type, and then it specifies what type of place it is. So it could be a retail store, a restaurant, etc. So I have now defined my location and place message. And I could also define scalar values, like how many check-ins were at that location, how many reviews that people have put at that place. So this is the simplest RPC call that you could define like this. So there's also another type of RPC. So something else that you could do is that you could use built-in types. So here's an example. This is an RPC call that allows the client to check into a particular place. And the way you do that is that the client is going to send in what place that they're going to check into, but I want to return an empty, right, for this. How do I do that? So the protocol buffers library has built-in messages that I could utilize. For time, for example, they have this message for empty, and then the way I utilize that is by importing it from the library like this in my RPC service file, and then I could just update my RPC call like this, and it will return an empty type on the client side. So this is a simple how to use built-in like messages that are part of the protobuf library. So, but what makes RPC calls really great is the reason why I use them is because you could stream messages. So let's look at server-side streaming. So suppose I on the client side send a collection of cluster of locations, and I want to know all the different places at those locations. And the server could send a stream of data, not just one thing, but a stream of data where each item in this stream represents a particular place in that area. So how do you define that? So here's an example of it. This is a server-side streaming call where I have defined a new message in the area, which is going to represent not just one location, but a collection of locations. And this is how it looks like. So I'm referencing an existing message here. I'm providing two locations. And in that area, I want to find all the places. So what's different about this RPC call, what makes it streaming is I have added a stream keyword right there, right after returns. And that means that the server is going to return a stream of place messages. So that's what that stream keyword is for. So this is how you define a server streaming RPC call. What about a client streaming RPC call? In that previous example, the server was streaming something, but I could also stream something on my end. So I could give a collection of locations as I go in my track, and I could have the server return me some summary. So I have a server could return a summary in this use case. So this is this example of how you could do that. I have an RPC called record trip, and I'm sending a stream of locations that I could send it at different times, and the server will wait, and then it will collect all those locations, and I could have it return a just one single type, which is a summary. And keep in mind, it's not a streaming return type. So the way you do this is using the stream keyword again, but now I have it on the request side, not the response side. And I'm sending a single message on the response side from the server. So that's how a client streaming call looks. Well, what about a bidirectional call? And this is good for example, for polling, a really good use case. So, one common use case is building like a chat room where you have users that could comment, at different times. So all those comments that people could make could be sent as a stream to the server. And then the server gives you the replies the other people make as a stream also. So you have streaming on both sides, the client and the server. So this is the use case that I use RPC for. So now this is called bidirectional RPC call. So, and keep in mind, I have on both the request and response side the stream keyword. Those are all the different types of calls that you could make. And this is how my service file is going to look using protocol buffers. So now I'm going to give this file to the protocol buff compiler. Is going to generate some code. And how does that work? So let's look at that. So when I perform a build, there's the protocol buff Gradle plugin, it's going to run that proto-C compiler, and the library, and what it's going to generate is some messages. Like for each message, like place, location, is going to generate a class for me to create it. It's also going into Coroutines library, will also generate coroutine bindings for those RPC calls that I just defined. So how does that look? So here's an example of what it would generate. So you have a message here, location, it maps to a Java class, which has a builder, and has a builder for setting each of those fields. So I could utilize this on like this using that builder, but what if I want to make it more Kotlin friendly, more DSL-like? So in the Coroutines library, there is a way to configure the compiler that it uses. There's a way to configure what generator that you want to use, some features of it. And I could have it generate inline functions like this by setting unwrap builders to true. And when I set that to true, what happens is that it generates an inline function like this. And keep in mind that parameter there is a lambda. Its receiver is a lambda.builder, and I could utilize this like this. So this looks more Kotlin idiomatic, much more DSL-like, and I could specify my location with latitude and longitude like this. So I could also have the library create DSL annotation markers like this. So that's how the library will create all the different types of ways to create my messages that I'm going to send. But what about creating my coroutine bindings? Let's look at that. So the way to configure it to create coroutines bindings for each of those RPC calls, you turn it on in your YAML file like this, specify like this. So when you do this, then you create a abstract class. The reason why it's an abstract class is because I will be able to implement, I will be able to inherit this and specify my own business logic that gets called when the RPC calls are made. So when you look at an RPC call like this is the simplest RPC call, unary RPC call. Get a place, and you get from a location, you get a place, and it gets translated into a suspending function like this, right this. So, but what about, so how does that work? So client sends a request, and then on the server side, it creates and launches a coroutine when that unary call is made. And it does it on a particular scope and on a particular dispatcher. And I could specify my own dispatcher, which I'll show you how that it could be used. So when that coroutine gets created, what the client sends the request gets called, given to the suspending function, and then it churns, and then it computes something and runs the business logic and sends a response to the client. And when you look inside the library, you'll see here that over here, by calling new RPC scope is a method inside of that library that creates a scope on a context. As you can see, it launches a coroutine with an atomic start and handles the request. So what about a streaming call? And the way that gets mapped into coroutines is like this. What is interesting about this is that the first parameter is the actual type, but the second parameter, because it's streaming, gets mapped to a channel or response channel that I could send things to. So a channel, if you don't know coroutines, so a channel is a way, a construct to send and receive messages. So when you look at a channel, it's defined as an interface in the coroutines library, and it inherits two different interfaces, send channel and receive channel, which have different concrete functionalities. Send channel allows me I could call this method to send something. I could check, is the channel closed for send, etc. And I would utilize this if I want to expose just that functionality for a channel. So I could send things to this response channel, different place, all different types of places. And what about a bidirectional call? How does that map? So the way a bidirectional call gets mapped is that now the first parameter, as you can see, is not a send channel, it's a receive channel. So I utilize that just to receive things from the client side and send it to the response channel. And you can see it's a receive channel type. So receive channel just has a functionality to receive something. I could check is the channel closed for receive, etc. And I could just expose that functionality with this interface of a channel. So that's how they built that API for these RPC calls, this Protopus library. So what happens underneath the hood? Underneath the hood, what happens in the library is launches a coroutine and it defines a channel, and I send my request to it and it gets it. And then I could run my business logic, and then I could send something to the receive channel and it sends it to the client. So that's how it works underneath the hood. And then, so it generates the low-level code to make the RPC calls for each of these methods in this abstract class. So I could override it and give my own business logic that I want to execute. So I'm going to create this class called place service. I'm going to inherit that class. And then what I'm going to do is that I could define my own context that I want to, my own dispatcher that I want to run. By default, it uses dispatcher.default. But I could specify like IO. But for testability, I want to be able to, in my test, inject a test coroutine dispatcher so that I could inject it in this class, and like this, and I could utilize that injected dispatcher like this. So I'm overriding this field called initial context to do this. So how do I write the business logic for a function like get place? So to do this, I would probably query my database to get all the places and filter it out. To filter it out to find the one that the client requests for a particular location like this, and I could send it back, and I could create a place object like this using my message builders, my Kotlin friendly DSL, and I could return it like this. So this is a simple example of implementing a unary RPC call. So what about how do you implement a server-side streaming call? So the way you might do that is that also here, query your database to get all the places for an area. So you would have business logic for that. And you could, in a for each, this is one way to do it, where each of the places that you find, you could send it to the channel like this, to the response channel. One question that comes up is that, how do I close the channel? So when you look underneath the hood, like in the library, you'll see that it does it for you. It will close the response channel once your coroutine goes to the end of the line, after it executes your business logic. So what about an exception occurs? What about an exception that occurs? So if an exception occurs, and when you look underneath the hood in the library, you'll see that it wraps whatever your business logic is in a try and catch and finally, and it will do cleanup and cancel the scope and propagate the error to the client. And so that's how error handling is done with that. So in the end, with the service, you could implement all these different types of methods that you want to execute when these RPC calls are made. So now we have implemented, a server, and how do we configure our server and then start it and specify what host and port to start it on? So Croto plus library is built on top of gRPC Java. And if you don't want to use coroutines, then you could just use gRPC Java. So gRPC Java has a way to create, to specify a server builder to specify what port and what services that you want to hook into. So you could utilize this by creating your server like this for a particular port. You could add any number of services that you want, not just one like in this example. And then after you build your server, you could specify that you're going to start it, and then you can hook into your runtime like this to shut it down. So then you would start it like this. You have a main method like in your microservice, and you could configure your server on a port, and then start it, and it will block until shutdown. Like it will keep running until you manually shut it down listening to your requests. So that's how you configure your server, and now we have a server setup that we could consume on the client side. So there are a couple of resources that you could check out. To check out the Croto Plus library and protocol buffers to see, what are different scalar types. You could also check out. So some people use Spring which also has support for gRPC. There is a framework that I use called Micronaut, which also has a built-in support for gRPC, and I highly recommend that framework. It's awesome. So you could check out those libraries. So let's look at lastly, how to consume what we just built in an Android app, building a gRPC client. So the library that we'll utilize, which was released a couple of months ago, is called gRPC-Kotlin. This is also built on gRPC Java. So the library that I use, so how does it work? So I define, as you saw, all the RPC calls on the server side. I'm going to copy that over and bring that on the client side in my Android app. I'm going to create a Proto folder. I'm going to set up my Proto buffer Gradle plugin to read from it, generate code, and it will generate a client stub that I could use, which has a lower level logic that knows how to make a request to the server. So what is inside of that stub? Let's look at that. How does it map each of the RPC calls? So this call, just like on the server side, will be a suspending method, like get place, give a location, get a place. So how does a streaming call get mapped? So if we hear the streaming call, the way it gets mapped is that the stream place gets mapped to a flow. So the server will be returning me a flow of places. And what about a bidirectional streaming call? A bidirectional streaming call, both the request and the response, they get mapped as flows. So I'm going to give a flow of comments in this example to the server. I'm going to get a flow of replies. So it will auto-generate code for each of these methods. And how do we utilize this? Generated coroutine stub. So first thing you need to do is build a channel. But keep in mind, this is not a channel like in coroutines. This is a channel concept in gRPC. And they provide you with they also provide like an OKHTTP channel builder or netty channel builder. So here I'm going to use a managed channel builder, generic one, which I'm going to specify what address host my server that I'm going to hit, and what port is it on. If I'm using HTTPS, I'll use transport security, and I'll have built my managed channel object. I could also specify an interceptor that will get called every time when I make an RPC call. This is good for like logging, etc. So when I do this, I have my managed channel object that I need to create. Then I'm going to inject it into this generated stub that the library generates, gRPC-Kotlin. And then I could use this to make actual requests. And the way you might implement that, in this example, I'm using view models from architecture components. I have injected my client in there, and then I could utilize it like this. In this example, I'm launching a coroutine on a view model scope, and I'm launching coroutine, and I'm calling client.getPlace on it to get for a location, get a place. The simplest RPC call that you could make. Over here in this example, this is a streaming this is a server streaming call where it returns me a flow. So what happens if an exception gets thrown? Well, this is going to crash, but you can handle exceptions by doing places.catch. and you could return like an either type from arrow if you want. So that's one way to handle it. Another way you could handle exceptions in coroutines by injecting into the context of this coroutine an exception handler. But I recommend like flow.catch extension to use. So the other thing, how does a bidirectional call get mapped? So if you have a bidirectional call, like this library takes in a flow. So you could have like a hot stream. So you could model that using a channel in your application if you're building like a chat room app where any people, anyone where when you're sending comments, you could push to this channel all the comments that you're sending on the client side. But then I could convert it, I could bridge that channel to a flow using consume as flow. If you're using a broadcast channel, you could do, there is a method called as flow. It's not consume as flow, it's called as flow. And that method will open a subscription underneath the hood on that broadcast channel. So that's a pattern that you could utilize. So I'm sending that to a flow, to this generated chat method, and then I could collect whatever the server will give me back. So the way this works is that I could send one thing, and then the server could decide to send me a message, or it could wait until I send multiple things. So it depends on the business logic that you implement. So in my view model, I'll have basically like methods for all of these implemented and business logic for them. So that's how I could utilize this client. But the question is, what happens underneath the hood when I call these coroutine methods on the client, suspending methods? What happens inside of that? So inside, what it does is what the library gRPC-Kotlin does is that it has a custom flow that it creates, and inside of that flow, it's going to take whatever you give to it. It's going to create a coroutine. We call it a consumer coroutine. And inside of it, since this library is built on top of gRPC Java, it will tell it, hey, start the client. Start the client. And after you start it, it gives it a request. And then it goes out, and then you get a response back. The response that you get back gets put into an array buffer channel size 1. And when it adds a response to this channel. It could be one response or two response. It will add all of them. And it will also, since all of this logic that I just showed, these two boxes are inside of a flow, it will call emit on that response to give it to the client side. So to you on the client side, what you're exposed on your end is a flow of responses. And so this is the overall setup of the library and how it uses coroutines to make any type of request in any type of RPC call. So that's how you interact using your view model with the client stub and how it works under the hood. There are libraries and resources that you could look at, like gRPC-Kotlin library. There's also a library called Wire. Wire is a really great library, a bit different in the way it sets it up. It has the concept of a gRPC client that you could use. So but it doesn't support everything in Perl 3, which is why I wasn't able to use it. But it's a really great library by Square, and so in this presentation we looked at how to build a server using gRPC server using Curtiplus, and also how to consume it on the Android side using gRPC. We looked at two different libraries and how they utilize coroutines. So I have a website, codingwithmohit.com, that you could check out. And I have written posts on like how do you test coroutines and how channels and flows work, and all that information is useful as you're interacting, as you're writing tests for your view model that I just showed. And you could check out my blog posts. I wrote a blog post on unit testing, delays, errors, and retries. So all those things are applicable here. I also wrote a blog post called Kotlin Assert Flow Delight long ago, which is now turbined by Square. That's the pattern that I use on asserting with flows. So if you, on the client side, you make an RPC call like to list places, returns a flow. In my test, like I could utilize this library and write more fluent like testing assertions for my view model. So also wrote on how channels and flows were, given more presentations on that. You could check that out if you want to learn about more use cases on using channels and flows. So that's my presentation. I hope that was helpful and you learned a little bit about gRPC. What's really useful that I utilize is bidirectional streaming, which is very useful for me personally. Thank you to Kotlin London for allowing me to present from New York, and thank you to Enzo and all the organizers for this opportunity.
Thanks to you. Really nice talk. Thanks very much. So we almost ready to switch to the second speaker, which is no introduction straight away. The second speaker, which is Uberto. As I said before, it's not his first talk in the Kotlin Meetup. We did like a couple of years ago, where we still could do Meetup face-to-face, but this time it's online, and he's talking about validity requirements and domain with the library he created, which is called Pesticide.
Hi everybody, hi, how's it going? So let me first, I don't know how to, oops. Okay. Okay, this is share screen. Okay. Yeah.
Yeah, it's the first time for all our speakers. So if you have technical issues, don't worry.
Yeah, that's the usual stuff, and then right, okay. Can you see Enzo?
Nope.
Okay.
So if you should have like a share screen and StreamYard, and you can choose a tab or a screen. Now I got it. There you go. Can you switch to the slides? Perfect. I'll remove myself and you're ready to go.
Okay, thanks everybody. And let's start with the talk. This talk is about agriculture, basically, how to prevent bugs with the pesticide. And since we are nice people, we are using organic pesticide and specifically ladybugs. But okay, let's start a bit about our software engineering problems. I suppose that most of you have this idea of quality will cost. And here you can see two cars, which are red. And probably one car is better. I suppose that if you have to choose one of these two cars, you probably won't have any doubts of which one. They have a different quality and a very different cost. And this is how we normally think about cost. I mean, you want quality, you have to pay, which is true, generally speaking, but it doesn't really happen to apply very well for the software development, as I hope to explain shortly. So this is the normal way.
I'm not sure. It's probably we have a technical issue. Trying to get back to Uberto. But can you hear us? I think it's freeze. Try to get back to him. Okay, this is unexpected. Okay, this is the first time we have technical issues during the meetup. So to get back to, but it seems it's being cut off from internet. See if we can get it back. But seems it's completely off internet. Try to get it back to him. No, it seems completely off. Try to restore its connection. Hold on. Let's try to get him back. We should have him back. Hey.
Hey, sorry, my computer crashed.
Oh, nice, perfect. I thought it was something related to internet, but yeah, it was
Really
even worse. No worries.
Sorry, let me share screen again. And
there you go. Perfect. You can go whenever you want.
Okay. I'm sorry about my computer just crashed, but we are back. So we were talking about quality. So the normal way to perceive a quality, the one that we are used, is that you want quality, you have to pay. So at the end of the day, you have to decide how much quality you afford to pay, and try to find the sweet spot between the cost and your quality. I mean, the top quality that you can achieve. This is definitely working for the manufacturer and other industry, but it doesn't really work like this for the software industry. And if you know this guy, who is called Martin Fowler, he has a very good post and books about this kind of concept, which is that high quality is cheaper to produce. Or in another way, if we have a project with high quality, keeping that project running and keeping the quality high is actually cheaper. It will require less effort than having a project with low quality and just keeping that project working. Because in software, it's different from manufacturer, where basically why a Ferrari costs more than a cheaper car, because it uses a better quality materials, but in software we don't have the problem of materials. And the other point is that Ferrari require more time to be built. Instead, the cheaper cars are done in a way that save time. But that's because once you buy a car, the car stays as it is. In software, instead, we have to keep changing. So it's a completely different industry. And if you try to cut all the corners that, for example, a very cheap car is trying to cut to keep the price low, it will make much more expensive to change stuff later. And this is why in software actually is cheaper to keep the quality high, which is kind of not intuitive. But then we have to think about what is quality. And there is this book, which is a book that it's very interesting how redefine quality for software. Instead of using some subjective kind of rules or guideline principle, the myth of the artisan, the craftsman. It's very statistical approach. Basically, it's you cannot really measure quality, but you can measure some. They have 4 main metrics: frequency of deployment, lead time for changes. So how often do you deploy in production, and how longer it will take for when you have something to deploy to be actually deployed in production. The medium time between release and the change failure rate. So how often you need to roll back a release because something went. How often do you do a rollback in production, basically? And basically the idea of this book is that you can measure these 4 metrics, and statistically the best company have a very high value in. They using these 4 metrics, basically you can get the better companies, and the company that have implicitly the better code quality. So the idea is that you are not going to measure your code quality in a kind of abstract sense, but using this kind of metrics. So if you deploy every hour or every few minutes, and it takes less than 1 hour to have something from ready to go in production, and also you have a very low rollback, and you take very MTTR is the time required to fix a problem in production. That means that you have a very high quality, regardless of a principle or craftsmanship or stuff like that. So if you have a high quality in this way and you keep the quality high, it will be actually cheap. And to keep the quality high, to be able to do this kind of continuous delivery, and be able to fix any bugs in a few minutes instead of days, there is this. We need an automatic test, and there is this idea of having a pyramid where we have a lot of unit tests, a bit less component tests and integration tests, and less until the manual tests are the more rare. We try to not do manual tests and instead using QA people to do exploratory tests and not just execute stuff that can be automated. This is all fine, all nice, but to keep the quality high, it's not enough to have the test. We also need to start write the test first. And in the project that I was working on, I'm still working, basically, the architect was Nat Price, who wrote this great book. And he was very keen that you should really write the acceptance test first, because that define basically force you to define what is going to test. So if you are not able to explain from a business point of view what you are going to write, is quite possible that you finish writing some code that is not really doing what was supposed to be done. And so we have this, from the beginning of this project, we have this idea that we need to write acceptance test first. And for acceptance test, we mean tests that are driven by the domain, by the requirement of the business, not from UI or some technical task. And this is more or less our problem. So this is a very high-level view of our microservice system. And these are all the square boxes are all microservices that have to be deployed. Every time there is a commit in production, we deploy. Every time there is a commit on Git, we're going to deploy the microservice in production. So it's quite complicated. And we need to be sure that every time there is a change, we can run all the tests and make sure that the change can go in production in a few minutes without stopping, without breaking anything else, basically. And also, the characteristic of our microservice is that they use the pods and adapter architecture. So basically, all the microservices are defined with the hub, which is internal. And from the hub start all the, they say that in the hub there are the ports, and then there are adapters that connect the hub with all the technical infrastructure. So login, authorization, HTTP, database, and so on. With this in mind, basically, actually, if we look better back, the one with the circle inside, they are service that have the hub inside, because they are doing something that is specific to the business. So they use the port and adapter architecture. The one without the circle inside, instead, they are completely technical microservice. For example, transforming somewhere a document to PDF or something like that. It's completely technical. There is nothing on business side. And so this is the idea of a domain-driven test. That is, okay, we have this nice architecture. We should leverage on this architecture to validate our use case. So we wanted to use the domain to validate the end-to-end working of the application, which is an idea which is quite different from the current framework like a Cucumber, for example, where usually you can write end-to-end test, but you need to use the UI. So the test is very specific to the UI, to the technical, your technical layer. And how we can do this? And the idea is that we have a representation of an actor that should be the abstraction of a real user that tried to do something. And we have two interpreters, basically. One that interprets the actor inside the domain, which is the arrow, I don't know what is mauve arrow, and blue arrow, the purple arrow, And the blue arrow is that instead is the HTTP interpreter. So whatever the actor does, it uses HTTP to translate. And in this way, we can describe the problem as a domain, but we can also execute as a and fully end-to-end test. And when you have a multiple microservice, it's the same thing. So the running the test twice. The first time I only use the hub, that is the internal of the hexagon. And the second time I use in HTTP, HTML, end-to-end, putting all together. And in this way, every time we have a small change, we can verify that everything works, basically, before putting. And writing this kind of test is actually quite fast. So this really allows us to deploy continuously and be confident that we are not breaking anything. Basically, my working on this, working with Nat, I came out with this idea. Okay, we can make it a bit of leveraging on Kotlin DSL, because it's a very nice language, and we can make this stuff a bit more fun to use, a bit more simple to set up. And I wrote this, it's a very small library that makes easy to use this kind of testing, DDD. And you can find on the GitHub, basically. And I will try to show you now. So this is a bit more specific. For example, we have steps, which are action that the actor does. So one actor can be add an item. And this item, this action, this step, basically got transformed in the HTTP interpreter in some HTTP call, then check back at the application status. And this is an item that actually changes the state. Some other steps instead are steps that assert that the state is in the way we expect it to be. For example, get items. And in this way, we write the step only once on using domain terms, domain word, and then the interpreter will translate in HTTP calls. But then the assertion will be done on the actor side, because the assertion will be a domain assertion. So we expect that the items are exactly the items that should be there. And the test itself completely is unrelated with the technical implementation. If we wanted to change the technical backend, we needed to change the HTTP interpreter, but we don't need to touch our test. And using this kind of a flow with the DDD also help us to guide in the design, because we start every time there is a new feature to write the HTTP DDT, and this will kind of nudge us to write a good design, something that can be tested, and to do the implementation. Once we have the implementation at the end, we write the unit test for the details of what we need to write the code to make this stuff working. And when today is a very bad day. When we are at the so first we define the HTTP calls, then the memory DDT. Finally, we write the actual code, so we can write the unit test. This will make the memory DDT work, and then finally we wire the final things to make the HTTP DDT work as well. So in this way, also it really give you a good pace to implement each feature. And now let's see exactly the test. So this is a actual code from our production, so it's not an example. In the GitHub repository, there are some examples I will show you, but this is from our production. And we are defining a flow for academic journal. And you see that this is the test, basically, and the test define what the author of a journal basically have to do to approve his article, basically, and his license. But this is very clear, like in English, because it's clear. And it's something that anybody can read and understand how the system works. So they also work a kind of documentation of the system. All the technical assertion, all the domain assertion are inside the actor. So the actor have this role as a kind of container of all the technical mess up that is needed, but that we don't want to see in the test itself. And when you run basically this test from IntelliJ, this is how it looks, because every test run twice. First in HTTP, and then in first in domain only, and then also in HTTP. And all the this is a bit of the framework that I wrote. Basically, it also substituted the name of the variables in the test name, so it's quite easy to read as well. And now I would like to have a coding demo, if there are no other problems. And so basically, this is the project that you can get from GitHub. Core is the actual library. And then there is another module with examples so that you can use as copy-paste inspiration for your actual project. And there are also some examples in Java, because the library is written in Kotlin, but also works for Java. Only that the DSL is not as nice as it is in Kotlin. And for example, this is a kind of, because the DDT have this idea of a setting, it's a bit like you have a play basically in a theater. So you set up your actor, you set up your background, and then you let the actor do the script basically. So I say, okay, let's do an example with a fable, with the Little Red Riding Hood. And we can see here, basically, this is the main story. So Little Hood goes in the forest. So first let's put the forest with a grandma living alone inside. And this is the setting part, which is not part of the test itself, but prepare the system. And then authorize, basically, this is the actual test. And then we can say, Little Red Hood go to with the basket, go to the forest, then get the big bad wolf, and so on. And we can also say, okay, let's do another scenario where basically Little Red Riding Hood avoided to tell the wolf about where the grandma lives. So if we use this scenario, at the end, everything goes well and nobody gets eaten. But we can also have a scenario without the hunter, basically. So the big red wolf eat the girl, and there is no hunter. So that's it. I mean, Little Riding Hood cannot jump out of the bed, and they cannot give the good to the mother. And you see, it's quite expressive if you write well, and then you can just run it from IntelliJ. And you can see here that there are the three scenarios: normal, wolf win, and smart girl. And in this case, it's only domain only because we don't have an HTTP application. But you can see that each single step gets translated in a test, an individual test. And if it fails, basically, you can just jump directly where it failed. For example, if we wanted to make that a different value for the goods when we run the test will fail. And you can see that the test is failing. And then let's do another test. Let's fix this one. Which is a bit more complicated test. This pet shop test is a real, it's a kind of an application. So there is an actual REST application that works as a pet shop. And so at the beginning, we needed to specify that the interpreters that we are going to use, which are two, but can be also more than two. For example, if you wanted to have an HTML UI with the JavaScript interpreter, for example, on the top. And also another thing that I should probably say is that the HTTP interpreter, it's using the host. In this case, it's using the local host. But in our system in production, we are using the staging and the actual the test environment, basically, to run the test. So not only we can verify that everything works locally, but we can also verify that works in the test and the staging environment. So in this case, for example, here is this idea of the hub. So this is our hexagonal architecture. And this is the domain-only interpreter. And the domain-only interpreter just needed to know one hub or more than one hub if you have a microservice. And translate each command directly in a command for the hub. So it's quite small and very simple. The HTTP interpreter instead needed to translate each command in a command to the server. So at the beginning, you have to prepare and actually start the server. And then it will basically translate each request, each command in a request that goes in HTTP, and then at the end verify that what's happening is what should be happen. And so this means that in the main, you see that there is actually a pet shop, which is with the full main, and you can start is a kind of REST application. And also the interesting part is how we write the test. And to write the test, basically, we define the actors using, this is a bit of DSL, but this is the actual actor. So in this case, it's a buyer of a pet. You can define a name, and then you can define which kind of actor is, basically, in this case. And everything that the actor does is defined as a step here. So you can see something, then step, and then you define what is happening in the step. So when we can write a test where basically the shop assistant check the pets, because shop assistant is another actor with a different type. So it can do different things. And in this case, for example, there are two. First, we set up the shopper with the two pet, and then we can check, the shop assistant can check that everything is in order. But then we can also have a story where Mary buy a lamb, and we set up the shopper with the lamb, and then Mary can check the price of a lamb, of an hamster, and then decide to buy a lamb and check out with the pets. And so on. And it's quite simple to write a new test for new scenarios. And if you have a question, I think you can do at the end, and I will answer. So let's go back to the presentation. If I found, yes. So wrapping up, what is the takeout? So domain-driven test help us in this way. We use the domain, not the UI, to describe the scenario. And we run the test multiple times to verify different abstraction level. And then we can express expectation at higher level, meaning that we are not just checking click here or click there, or verify that this box is green, but we can define expectation as a domain language. So the benefit is that we can test the feature end-to-end. We can document how the story, the feature should work. We make sure that there is no logic in the infrastructure layer, because if someone put some business logic in the infrastructure layer, the domain-only test cannot pass, basically. And also we make sure that there is no infrastructure detail in the business logic. So inside the hub, everything must be very pure, very defined as a business. And all this rule is not making harder for us to develop, but actually they give us speed at the end, because we can change things very quickly, because we are completely confident that our automatic test will detect any errors. And also it's quite easy for us to add the new errors or new logic. Sorry, new test or new logic. And this is basically how the process. So first we write the HTTP DDT, then we implement the adapter, so the external shell, basically. This will give you some hints how to define the model to solve the problem. So then we can write, once we define the model, we can write the in-memory DDT, and then we can close the gaps with the HTTP communication if there is anyone. So that this is my social media handles. If you wanted to ask me a question or read, there is in my blog there is a post about this, and you can follow me on Twitter, and now you can ask me questions.
Okay, I think we don't have any questions. Just one comment about the 4 matrix in the YouTube comments. They say, as far as I know, those 4 key metrics from Accelerate are not leading metrics about quality, but about business performance, as they translate to IT agility. Good metrics to have nonetheless.
But that's exactly my point, that my concept of quality is business agility. I don't want another concept of quality that is different from this one. I mean, I cannot measure the internal quality of my code directly, but indirectly I can use using this business agility, because if my code allows for business agility, that means that my code is good. And apart from that, I don't care basically how I can get my code is good if it allows for business agility. I'm completely fine. This is my point.
Cool. So if there are no other questions, we say thanks to you, Uberto. A very nice talk, and thanks for being here.
Okay, well, you're welcome.
Right, I think that's it. Thanks again to Mohit, Uberto, for being with us today, for letting us to speak at our meetup. Thanks to my co-organizer, Pablo Amar Guillermo. Thanks so much for tuning in. Hope you enjoy with some small technical issues. Let us know if you like the new way we do the streaming. Just the recordings will be available straight away on our YouTube channel. So subscribe to YouTube channel and check the meetup page for our next event. We hope to do it as usual. The first Wednesday of the month will be so early September. That's it for now. See you next time.